been going for a while. Sometimes there's a little bit of a memory leak. And we'll see her come. extendedutxo.org. Look at all that stuff. 668 total transfers, intra-wallet transfers, 606, foreign account transfers, 62. A nice little NFT drop is going on there. Like the blocks are saturated. You guys over Twitter, you notice that. You say, damn, blocks are full, yo. Isn't that cool? So let's talk a little bit about scalability and what this means to us. So first off, blocks being full, Cardano is designed for that. In certain systems, like when you have an engine and you run an engine at redline for a long period of time, and it's really to the left here, if you run an engine at redline for a long period of time, what happens? The engine breaks. Oh no. But actually the Cardano's design is a little different. When you have a blockchain and you have all these nice little blocks and stuff is happening, if they're completely full with Cardano, it just carries over to the next block. And it doesn't really throttle or slow down the network from a perspective of we're worried that somehow things are going to overflow and collapse. Whether your block is at 0 kilobytes or it's at 88 kilobytes, Cardano reacts much the same way, and it has a ton of throttling mechanisms to basically react to periods of high load and low load. So there's a question of how do we achieve scale inside this system? So scale is a multi-parameter model, and I'm going to give you guys some of the rough points to it. So first off, there's increasing block size, and there's decreasing block time. So block size goes up, decreasing block time. So the time it takes to make blocks goes down. And then there's also more efficient transactions. So you accomplish the same amount with, roughly speaking, the same with roughly speaking smaller transactions. So when we look at the network right now, our block size is running 88 kilobytes. And when you take a look at things like ICANN, for example, this is an example of where we've gotten a 10x in transaction size reduction between Plutus V1 and ICANN. Same for Plutus V2 and more efficient utilization and usage. So the question is, do we have more room to expand this block size? And can we do a little bit better on the broadcast so that we can have more blocks per second? And the answer is yes, we do. We actually have the ability to do this within reason. And there's actually a committee made up of community members and engineers that's looking at both of these things. What optimizations are on the horizon where one can increase the size, decrease the block time, and also language improvements and DApp improvements give you more efficient transaction. So you kind of put this under the optimizing. So you do more with what you have in the existing system and protocols. Then the second category of things you can do is over here, and that's basically the layer 2 game and the batching game. Okay. And there's a litany of other things there. And so this is really when we look at things like Mithril, we look at things like Hydra. Okay. And if you take a look at Hydra in particular, it's growing at a very rapid rate. If you go to Twitter and people talk about it, say, oh, it must be a failed project because you've been talking about it for a long time. Well, yeah, here's a live look of the roadmap, and you can take a look at things moving through. And it's actually a very well developed open source project. And there's a lot going on with Hydra, a ton of commits, a ton of things, and it's been making a progress. There's been releases, and there's a whole open source community that's forming around Hydra. And you can see how we've kind of worked our way down the feature set, so head-to-head protocol, single head per node, WebSocket configured, terminal use, etc. And all of a sudden now we're working on incremental commit and decommit, which is a major extension of the protocol, modularizing things, and more on the roadmap. And the roadmap is here. So what does this translate to? It translates to, instead of doing things in your first category where this is all on chain, you start moving into a paradigm where you go and you're doing a hybrid where there's an off-chain part and there's an on-chain part, and that on-chain, off-chain relationship gets a little easier. So Hydra is kind of that linking tissue between the two. And then you have flavors of the protocol. So some of the flavors historically mentioned, like the very high TPS flavor, when people were talking about 1,000 TPS per head, that's where you were talking about things like a tail and payments protocol. Where that would be relevant would be for tipping, micropayments, these types of things. And that's an extension. So what the head does for you, Hydra proper, is it opens up a whole bunch of flavors of Hydra. And those flavors basically have different capabilities. And the same infrastructure and architecture is used, but how the heads work, coordinate with each other, and the complexity of the back parts of the protocol, as well as the primitives that those protocols use, they basically give you more capabilities. The same could be accomplished in rollups. Same could be accomplished in recursive snarks, so the ZK world, and you'll see a lot of projects going down that road. But generally speaking, these frameworks. So kind of our first entry point, the proofs, is Mithril. One of our first entry points to this bridge between the on-chain and the off-chain is Hydra. So these are both in deep R&D and deep community development. Hydra is on the Cardano mainnet. People can use it, and they're starting to do things. And what happens is, as we get deeper into the Hydra roadmap, you start getting much more use and utility. Like, for example, when you get incremental, decommit, and commit, at that juncture, you can start talking about doing poker and blackjack, a whole bunch of interactive games, these types of things, especially when you also automate rollbacks and these types of things, the relay capable. So enormous amount of progress has been made. The hardest parts of Hydra are over from the perspective of actually deploying it, getting it to work on mainnet, and building an ecosystem and community around it. And there's already a lot of contributors, 39 contributors to be exact, that are on the list. And these contributors are every week showing up at meetings, talking to each other, and doing interesting things. And so it's a very vibrant project, as is Icon. It's a very vibrant project. Going back to tap tools, you can also see all the different cool, interesting things on Cardano. SingularityNet, for example, $2 billion ADA, $1.5 billion project on Cardano. Wrapped Ergo is also looking really good. There's just a lot of cool and interesting things that are in the Cardano ecosystem. And it shows you that we're in a very different world than we were just 12 months ago. So the big thing, though, is the question of, can we do better than the base protocols that we have? And better has a bunch of different meanings. So better, and I kind of look at this in three categories. So the A category is better in terms of finality, because it's not necessarily just about, can we do a lot of throughput? Does it settle quickly? For a whole bunch of use cases. ATMs, you buy something at the grocery store at the point of sale. So you buy your cup of coffee. Does it instantly settle? Vending machine, this type of stuff. Okay, so you want fast finality. And we have a lovely paper. It's almost ready to publish, called Paris. And we have a whole R&D team that's been working on Paris and doing some really remarkable work. It's led by Arnaud Bailly, who is the same person who works on Hydra with the rest of the team. And what this functionally does is adds a fast finality capability into Cardano. So the first use case is going to be with the partner chains. So you have Cardano SL, the main network, and then Cardano CL. And we also call it the Cardano asset and settlement layer. So this is the old parlance, and this is the new parlance, and Cardano service layers. So partner chains. And basically, when you want to move stuff back and forth, you want fast finality in that transaction. So this is what buys that for you. And there's an enormous amount of work with Paris. And that's something that's near horizon, in that it's something that we can conceive and imagine being in the roadmap this year or next year. The same team that's actually implementing Genesis, Twig, is likely going to be the implementation team for Paris, depending upon negotiations. So fast finality is one component. No matter how much throughput you want your settlement times to always be going down. Second, you have this concept of, okay, I want to have special networks that provide services. And this is the whole partner chains model. So when you actually take a look at the stuff that's happening here, you go over to extended UTXO, you see these blocks. These aren't just blocks, well, transactions. These are transactions that have nuances about them. So yeah, there's some NFTs being issued, and there's ADA handle, and there's scripts being issued, and these types of things. But if you pull these things out, some of the things that are happening, like right here's Wing Riders, for example, some swaps that are occurring, some of these things that are happening, they would be better suited in a network with a service layer. So here's a great example. Let's say you have Cardano ASL, so the main net. Okay. And then we have a partner chain. And let's say this is next generation Singularity Net, and they have an LLM that's like ChatGPT. So we'll call it Ben GPT. Okay. Ask Ben. All right. So instead of using ChatGPT or Claude or something like that, basically what you do, you would send a query as a transaction. It would process and do some thinking. And the brain here would be like, oh, yes, I have an answer for you, and send it back as an oracle. Be like, yes, here's the answer to your question. Okay, well, these systems could process potentially millions to billions of queries per day. If you open AI, you have a ton of stuff going on. Now, the question is every single time you ask a question and send some funding to answer that question, should that be preserved forever? Should those queries also have the same level of publicity? So maybe you send a picture over and you say something like, what is this rash? Do you want that being known by every single person in the entire Cardano ecosystem, that rash on your ass, the butt rash? Is that something that you really want everybody to see? Well, maybe there's some perverse weirdos out there, but maybe, just maybe, you don't want the whole world to know that you have a rash on your ass. Okay, but if you sent that through to a public network instead of a service network, then potentially it would have the same level of transparency as Cardano. Also, that is preserved as a query because of the way blockchains work in the blockchain forever. But as a partner chain, that service network would be able to, by the way, you'd pay an ADA for that, or whatever the native currency is that you want to transact in, the whole concept of Babel fees. But as you send that query in, but maybe, just maybe, you just want the answer, and that comes in as an oracle, but it doesn't necessarily work its way through. So when you really think about it, every one of those blocks are filled with a whole bunch of traffic, and maybe some of it's world mobile, where they're going to have millions of customers, and those millions of customers are going to be connecting their phones, and there's a handshake to connect their phone. There's purchases on a daily basis of some bandwidth, all those things. Those are millions to billions of transactions, even for a modest scale network, on a monthly basis. And we imagine Iagon is another, you have decentralized storage, these types of things. You have all these dApps that live here, and the dApps have elastic consumption of resources. And maybe as they gain users, they're constantly buying temporary space for the account profiles. And as long as those account profiles are funded, they'll stay, but then they go away. Okay, so you can imagine all these things. So special networks for services is another big component of scalability. You have to segregate what you want to keep forever from, and public, from what you potentially want to keep for a while or user defined, like rent, and potentially you want it to be private. That's what Midnight is doing for people. By the way, Midnight can obfuscate queries to Ask Ben. So partner chains can also talk to partner chains, and maybe Ask Ben stores all of its training data on the decentralized storage network, or these types of things. So partner chains can do partner chain to partner chain transactions, and they also can be query points for your dApps. So this is a very important part of getting scalability, because it's not just running billions of transactions, because if you run them under one model, they're forever and they're public, and then everybody knows about your butt rash. And also, you have no ability to have nuance in your storage. Okay. The final part, which is what most people are interested in, this is the sexiest part. It's had many names: parallel chains, input endorsers, Laos, etc., etc. This is under heavy, 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 heavy review and construction, and this paper is almost out. I've been saying it for a while. Agalos and I go back and forth on this one, but we're actually pretty happy with the direction this is going. Now, what that does is allows us to go back. You remember my whiteboard video where you don't really have a blockchain anymore. Blockchain, you have things in a very sequential way, and they're of different sizes, and they all are linked to each other, right? You kind of move to a different model where you have a whole network and ecosystem of stuff that happens asynchronously. Okay, and this ecosystem of things eventually gets stitched back together. So you have all this stuff in here. This concept of input blocks and key blocks. Now, what this allows you to do is massively improve your throughput, and your throughput is asynchronous. Okay, so your TPS rate, or in our case, TPT, transactions per transaction, goes way up. Way up. And you have to reconcile it. So there's a whole bunch of magic in the security world that goes into how that reconciliation happens. But you're never really throughput limited, as long as things don't contradict each other. It goes into this blob. So for example, right now we're under load because I think there's an NFT drop going on, and typically that creates a high degree of load. So it just happens. Things are occurring. It's not really a problem. At some point, it stitches itself back together. And there are special rules within this blob to do this in a way where you can't contradict. And that's the proof in the pudding. It's very easy to do asynchronous high throughput, but when you have conflicts, usually what happens is the whole thing goes to hell and the network falls apart. So optimistically, awesome. Pessimistically, you're fucked. The network actually is slower than the sequential case. So a lot of cases, you'll see these DAG networks, decentralized acyclic graphs, and they say, oh, we're so fast. Like Red Belly is an example of that. It's a BFT protocol, and they're super fast. They go several 100,000 TPS is the optimistic case. Massive speed, 100,000, 200,000 TPS. Another example of that is Narwhal and Tusk. But if a malicious pattern comes in, you go to the other state, and then suddenly that goes to hell, and you're as fast as a sequential state. It's always the issue with these types of things. Leos is a major step forward because we thought very carefully about that, and because that careful thinking took time, that soon right there is a little longer than I would have hoped, but we're at the finish line. And basically, we now have a model for how to get what people would want, which is very high transactions per transaction, but at the same time, actually can recover nicely from various attacks. And you'll see a sprinkling of papers that we've written along the way, like Ledger Redux is an example. Then we had another one, Ouroboros Scats. Can never pronounce the full name for it, which is basically recovery from attack. And then we also wrote the parallel chains paper and a litany of other papers throughout the years that basically built a conceptual framework that's allowed us to build our way up to this optimal high throughput protocol that we have. All right, so why don't you just start here? Well, let me show you a picture, and I think this epitomizes why you start over here first, and then you start building extensions, and then you actually start getting to high throughput protocols. So let me show you a little something. So if you go over and you watch Mario Brothers 1, the very first Mario Brothers game. So this ran on the Nintendo. And look at that user experience. Pretty remarkable, huh? Oh yeah, we all remember playing this game when we were kids. Very low powered hardware. In fact, let's look up the Nintendo NES. The original Nintendo Entertainment System. It is a 256 by 240 pixel to standard display. The PPU is the RICOH 2CO2. Very simple 5-channel APU. It is a remarkably simple device. Okay, the hardware is incredibly simple inside of this. A lot of design flaws, problems with the lockout chip, technical specifications. The processor is clocked at 1.79 megahertz to 1.66 megahertz. Think about that. The CPU has access to 2 kilobytes of RAM. It's pretty crazy. Picture processing unit, 5.37 megahertz. It's like, there's just nothing here. Okay, this is as bare bones as it gets, which is why it's not surprising when you see Mario Brothers, it looks like this. But here's an interesting thing. Same hardware. Generation later, get this. No changes in the underlying hardware. How about that? Look at that. Radically different game. You have overland maps. You can fly in the air. So you're doing all this cool stuff. Much better soundtrack, much more interactive. Very same hardware, same cartridge. But somehow, some way, they were able to get to that experience. Isn't that pretty remarkable? So that's why you start on the left-hand side and you talk about optimization. So more efficient transactions. You talk about optimizations to the existing protocols. And then you can talk about extensions. And then you say, okay, now let's actually, once we have the most optimized optimal model, let's start segregating things. And we break it down into stuff that you need now and quickly. Also, there's transaction prioritization. That's kind of a hidden, and when you talk about fast finality, there's part A1 and A2. And here you're also talking about things like tiered pricing. Why? Because when you submit a transaction, do you care if it settles in 1 second? Do you care if it settles in 10 seconds? Do you care if it settles in 100 seconds? Do you care if it settles in 1,000 seconds? What's your time horizon on that transaction? Well, let's say that you're at the cash register. You're probably living in that 1 second to 5 second range. You want it to settle quickly. Let's say that you are parking a car and you're paying for that receipt. Maybe the 10 second, 20 second range, not too bad. Okay. Let's say that you're at a restaurant and you're eating and you give your little credit card, and maybe the 100 second is not necessarily too problem because you're sitting there drinking your coffee. Okay, let's say that you're doing shipping and your boat has just gotten to port. It's checking in all the inventory at night, and the inventory is not going to be checked until the morning time. Any of these is fine because you have hours, maybe 8 hours before you even talk about any of the desire to settle. So as long as it just the guys show up in the morning and it's good, you're good. So pricing should work differently with a finite resource based upon the settlement desire. Having tools to accelerate your settlement time and tools to price it is very important because you get sculpting of traffic, just like packet prioritization and networks. You have something called like quality of service. Okay. Software-defined networking typically has this concept. So not all packets are equal. And then some of the traffic and transactions you're doing, they live in a broader ecosystem, but they don't necessarily need to settle on mainnet, or they need to be batched. So there's a very close relationship to these special purpose networks. I love it when Wacom does this. It goes way far away. There we go. And Hydra. Why? Because you can connect these two concepts together. Hydra also is a special ephemeral network that you're setting up for your specific case. So for example, let's say, remember the Mike Tyson fight that's going on, and Mike Tyson is going to fight Jake Paul. Now that's going to require a surge resource. So let's say that there's a live stream going on and you can tip real time Mike Tyson or Jake Paul as they're fighting each other. That'd be a pretty cool thing for Netflix to put in. All right. Well, we think there's going to be somewhere between 20 to 50, according to Netflix, million people that are going to watch that game real time. Let's say all of them are users. Okay, so you have a gargantuan surge of consumption for a 3 to 4 hour window. Massive amount of bandwidth is required. Okay, so that world mobile chain right there, that's going to be working real hard to do all that live streaming and broadcast for those 20 to 50 million people. There's an entry point. They have to pay, let's say it was pay-per-view, but it's actually Netflix, but they have to pay to get access to it. And then while they're watching, they're to be tipping. So you could set up a special purpose Hydra infrastructure to basically tip these two accounts. In real time, you can tip, and there's a batched settlement at the end of the fight for both Mike Tyson and Jake Paul. So on the main chain, the only thing that happens is that funds get batched together and a giant transaction occurs at the end of the fight to settle to Mike Tyson and to Jake Paul for whatever they've gotten tipped. And then some stuff happens with World Mobile and some stuff happens with that Hydra head, but relatively de minimis. So even though 20 to 50 million people are watching, the main network doesn't deal with that type of load. You need these cases for surge heterogeneity. Okay. You need ability to surge for these types of use cases. Well, these NFT drops are basically smaller versions of that. An event is declared, we know it ahead of time, it's been broadcasted, and having the ability to reconcile off and on-chain infrastructure means you can load balance it and you don't use that finite resource. And while this is going on, if it is surging the network, you could pay extra to basically get tiered pricing. So you get a settlement within a window, but now it's connected to the load of the network. Just like you have surge pricing for highways, for parking, any of these things where you have a finite resource and you have times where it's open, times where it's saturated. Now, after you have all these mechanisms, you've really thought about it, which we have as an ecosystem, and there's dedicated teams on all of these things, community controlled and coming online with SIP 1694 and also institutional stuff. There's already a vibrant open source project building out the Hydra ecosystem, and it's growing quickly. Paris is in deep R&D, and it's getting into the pipeline for it to be implemented like Genesis. Tiered pricing is in R&D. People are thinking about it, and obviously huge effort going into partner chains. Then and only then do you really start thinking about this, because you've already optimized. You already have all your capabilities sorted out, and this is where you get to global scale as a network. Okay. Why? Because you have all these advanced proof structures, and I didn't even mention the zero knowledge stuff. That kind of fits in the second category here, kind of 2B, the ZK world. So you have like rollups. Plutus V3 is bringing this in. That's coming along with SIP 1694. And we have a huge house of things Midnight is constructing that can be backported into Cardano. But only after you've kind of optimized all of this do you really start thinking about the global scale side, which is why Laos was a parallel effort, but a longer arc effort. Because once you get here, then you are talking about big bubble main chain. Okay. Here turns to here in terms of TPS. You have an enormous amount of stuff. Okay. So your data requirements go way up. Your data storage, your network requirements go way up. Your CPU requirements for validation go way up. Laos makes this a parallel process where basically people don't have to be gigantic supernodes to calculate all of this, but they can actually do that in that big blob here. And then there's just a higher overhead there. The network side of things and the data storage side of things, no matter what you do, you're going to have to assume a higher bandwidth in the network, and you're going to have to assume higher overhead for a full node. Well, hang on a second here. Doesn't Mithril give you something to say about that, where you don't necessarily have to have a full node, and yet you can still act as if you had one from a security perspective? Yeah, okay, so we built that. And then also there's plenty of ways to reconcile and handle the network. They're kind of built into the network stack we designed for Cardano, but it took a long time to build out and develop that network stack, but now we're coming to the other side of it. So these protocols, if you implement them naively, what they do is they lead to mass centralization, because what ends up happening is only a small set of nodes can actually process the high TPS that you're dealing with. Okay, they have to have things like 128 gigabytes of RAM or 256 gigabytes of RAM or even a terabyte of RAM for the mempool. They have to have huge CPU clusters to process all the transactions. And you talk about petabytes of storage. Now, are you running that on your Daedalus copy? No. So do we have a homogeneous network? No. You have a network that looks like server and client. And isn't that Web 2? Whoa. And that's the fine print on a lot of these current high performance protocols. Under the hood, the set of people that run the system is much, much, much smaller than the set of people that use the system. And you start converging to server client. So the first thing that you want to do is you just want to get your story sorted out. You want to go from Mario Brothers 1 to 3. This is Mario 1 to Mario 3. Mario 3 is as optimized as it's going to get. You can't make Super Mario Brothers with the Nintendo. It wasn't possible to do that. And what we've done through several generations of the technology is we've gotten from Mario 1 to 3. People are starting to get very clever about all of this stuff. And then what you want to do is be able to have extensions and accessories and new capabilities that are pluggable. Because then you've opened up the ability to extend the protocol, and then you get to the final part of the story where you allow this large bubble to occur. There are 3 principles that matter a lot to me. So one principle is this idea of inclusive accountability. You'll hear me say it again and again and again, inclusive accountability. And all that really is if you're Bob and I tell you something, you hear something, some knowledge K, you can verify it yourself. You can determine the truth value. So if you tell Bob, hey, Bob, it's raining outside. Okay. So let's draw our, how would Bob verify that? Bob can look, and Bob says, I have eyes. I can see the rain. I can hear the rain. I can verify it's raining. Can't see the rain, can't hear the rain, can't smell the rain, can't get wet. I don't know. I don't think that's true. So inclusive accountability. So what ends up happening in modern, naive, high-performance cryptocurrencies is that you lose this property in general as the system gets larger, because fewer and fewer people have the machinery and mechanics necessary to be able to verify themselves. The history they're looking at is okay. So you go from, I checked it myself, to trust me, bro. Now, if you don't care about this, if you don't think this is important, okay, but this is the crux of Satoshi's vision. If you read the Satoshi white paper, his assumption was all Bobs are equal. Every Bob is running a full node, and they're all transmitting and communicating with each other. It's a heterogeneous network. You can always check what you get. You have enough information, and so it's trustless instead of trust me, bro. Okay, so you don't care about Satoshi's vision if you don't care about inclusive accountability. Doesn't matter if you're a maxi or not. The second property that's really important is a property that's related to universal access for resource providers. I do not like the idea that only a special small class of people get to manage this bubble. I think it's a bad idea, okay? And Bitcoin mining is moving in this direction. It's really expensive to Bitcoin mine at scale. You got to buy ASICs. You got to have access to cheap power. You actually have to have a location to put racks of ASICs in. If you're living in a small apartment, you're going to get super hot in the apartment, and nobody wants to do that. And you think you're a drug dealer because your energy consumption is way high, and they think you're growing pot in your apartment. Doesn't make a lot of sense. Okay, so universal access for resource providers. Like if you have some sort of computer, no matter how powerful that computer is, you can play into consensus. Turns out that the current model over here is not as optimized as it needs to be. So a big design requirement of Laos was to improve the accessibility. So what does this mean? That the number of SPOs actually goes up. So we go from several thousand. The hope would be to tens of thousands. So there's a lot of protocol thought that's going into this as well. So that's a capability we're very interested in. Inclusive accountability, universal access to resource providers. And 3, to preserve the security assumptions and model. So Ouroboros, semi-synchronous, 51%, 50% plus 1 Byzantine resistance. That's the story. You don't want to go to a protocol like this and one half goes to a third, goes to a fourth. And also, you don't want a situation where when you have adversaries, so as your adversarial behavior increases, your performance goes way down. You don't want bad to map to performance like this. You don't want that to occur. You want a situation that you have graceful failure. So we have graceful failure, self-healing, 50% Byzantine resistance, a litany of these assumptions built into Praos in Genesis. As we go to the new realm, we want to preserve and protect those things. Turns out that no one, you hear like the blockchain dilemma, no one has really solved this. And we're the ahead of the pack in terms of the theory and science for how to resolve and solve these types of things. But it's a bear of a problem. And we have certain superpowers, like, for example, extended UTXO is a superpower. Mithril is a superpower, and other things that I think are going to really help the story of inclusive accountability. They're going to help the story of universal access, and also going to preserve and protect the security assumptions and model that we have. Now, here's the thing. While all of this is going on, you can continue optimizing and improving. You can continue moving stuff into Hydra channels. You can continue writing more efficient programs. We can optimize the code. All of that can happen. Okay. So that's currently like last gen. Just like you can write games for the NES while you're waiting for the Super Nintendo, while you're building that up. But this is a major protocol re-architecture and redesign, but it learns and is inspired from these capabilities. This paper is coming soon. I promised Agalos I wouldn't give people the date, but it's sooner than people think. And Paris is actually going soon as well. There you go. Now, what does this mean for Cardano today? Well, what it means for Cardano today is you live here where blocks can be full. And what does this mean for your usability of Cardano? Does it fail? No. Does it fail? Does Cardano become absolutely and utterly unusable for months at a time? No. Doesn't become unusable. Does it mean that your security goes down? No, your security doesn't go down. All it translates to is that there's a high load and user experience is not as good as it needs to be during those high load windows. Well, off-chain, on-chain, what you do is you do the same thing the Mario 1 to Mario 3 people did. You find clever hacks and optimizations in your protocol architecture, your application architecture. So maybe, for example, if somebody's submitting a transaction, they sign it. What you can do is you can just put it into an off-chain batcher. And it'll relay that when the markets open up a little bit. But from the customer's perspective, they've already signed and transmitted that. And maybe they get access. Like, for example, you're issuing NFT books. So as long as it's in the batcher, they get access to the intellectual property and they can see it, read it, interface with it. From the customer's perspective, the transaction's already settled, but the off-chain transaction hasn't quite settled yet. It needs to be included in the blockchain. But the funds have been sent. These things are there. There's all kinds of things that you can come up with that basically allow people to come around, especially if you have custodial wallets or these types of things. So this is the challenge. Just like any good game developer, you always want a faster GPU. You want the RTX 4090. But what do you do when they have ARC integrated graphics? Not all your customers are going to be able to afford a $1,600 supercomputer GPU. Sometimes they have integrated graphics. So what are you going to do? Tell your customers, well, you can't play the game. No. You find clever ways to make it usable and playable, but you degrade in ways that the user doesn't necessarily care as much about. That falls upon the application developer. There's still a lot of dApps on Cardano using Plutus V1, which are 10 times larger, the transaction size, than Icon or Plutus V2. So just by rewriting that, they could save an enormous amount of block space. You go from using 88 kilobytes to 8 kilobytes. Tell me, should we 10x the block or just push those dApps to upgrade their code so that they use it more efficiently? They're basically saying the only way I can get to Mario 3 is give me a Super Nintendo. But wait a minute, didn't Nintendo create Mario 3 with a Nintendo? They did. So that's a big component of it. these new structures and capabilities that come on, they're trickling out hard fork by hard fork, and they open up completely new worlds that people can use. And that's important. And some things are on chain, like Hydra, that have this strong off-chain component, and they can be accelerated over time. From our part, it's a huge amount of R&D is going on, and it's easy to get high TPS if you don't care about inclusive accountability. You don't care about universal access for resource providers, so having lots of SPOs and decentralization, and you can compromise the security model and rapidly centralize the system. In other words, if you want to be Amazon Web Services, Amazon Web Service level performance, if you want to be a cryptocurrency that follows Satoshi's vision and has your ability to verify, lots of people providing it so it's very decentralized as measured by EDI, and you want to have strong security assumptions, well, if that's what you want, you have to have a new protocol, because there aren't any on market that have these capabilities. And the good news is that a lot of scientists have spent quite a bit of time looking at this whole thing to figure that part out. So you hear a lot of stuff over the internet. You hear a lot of stuff over Twitter. You see a lot of FUD. And if you take a step back and you ask yourself, what are people really complaining about? Are they complaining about the fact that they're losing money? No. Are they complaining about the fact that Cardano has shut down? No. It's not even unusable. If it was unusable, transactions wouldn't be going through. They're complaining about the thing the very same people were calling a ghost chain with no users and no utility is being used too much. It's like a restaurant where the wait is too long. Does that mean the food is bad? Does that mean that the service is terrible? Does that mean that it's going to be a failed restaurant and they're going out of business? I don't know about you, but if I'm running a restaurant where every day there's tons of people at the restaurant and I get high ratings and a great, consistent, high quality product, I'm thinking about how do I franchise the restaurant instead of, God, this restaurant's going to go out of business and shut down. That's literally what people are complaining about at the moment. And of course, they won't complain about it in a few days when these drops end and we go back to normal baseline usage. Then we're a ghost chain again, and there's no use and utility in Cardano, and everything's going to fail, and nobody cares about us. So it's a complicated thing, and people like simple things. And when you hear again and again, oh, well, this chain over here has all these solutions, they very well may have come up with a very creative way. And there's plenty of protocols out there to do this to achieve high TPS. But the devil's always in the details of, does that come at a cost of decentralization, fragility in terms of the people providing the resources? Does it come at a cost of your ability to verify claims, and ultimately a reduction in the overall security model of the system? And is that an optimal state where everybody's honest and there's no bad transactions? Or is that an adversarial performance load? When you actually start asking those questions and going into those questions, then it's a little bit more complex. And then even if you do have all this TPS, as game developers have today, you have no incentive to optimize. When's the last time you've seen a game developer on an already shipped title issue a patch to improve performance of that game by 30% or 40% or 50%? They have no financial incentive to do it because resources are too abundant. Back in the old days with Nintendos and you're doing assembly programming, every single thing that they were putting into memory, they had to do it by hand, and they knew how to optimize these types of things. So it was so pathologically optimized that it was hard for them to adopt these new paradigms, because look at what they were dealing with. 1.67 megahertz, kilobytes of memory, not even megabytes, kilobytes of memory. But now everybody's got 16 gigabytes, 32 gigabytes. So if you prematurely open up the high scalability side, A, you're not ready from it from a protocol perspective, and B, nobody knows how to optimize their software, and they don't develop best practices, and you end up wasting 40, 50, 60% or more of your block size in junk and garbage. The other thing is you develop less of an appetite for your layer 2, so you starve that entire ecosystem, which is really important for the surges like the Mike Tyson versus Jake Paul example, where that's an ephemeral event. It's a one-time thing. It's going to happen. It'll have a beginning, a middle, and an end, and potentially provoke billions of transactions. You don't want those transactions forever stored and reconciling in your system. 100 years from now, they're all there. Does that make any sense to you? Is there any benefit to knowing that Jim and Bob and Alice had some hot dogs at the Dallas Cowboys game to the Dallas Cowboys concessions people, but is that something publicly recorded for the rest of time? And we all have to pay that cost forever? Doesn't make any sense. So it's a nuanced, heterogeneous thing. And it's an interplay between what goes off-chain, what goes on-chain, clever tricks just like game developers play to basically focus in on the user experience. Like, for example, when you play these big games like Skyrim or other things, what's really happening under the hood is you have the field of view of the player being rendered, but it's actually not rendering all the other stuff. The human eye works the same way. You have a focal point, and at any given moment, you can only really see around that focal point. But when you widen the aperture, you're actually not seeing as much detail in your peripheral vision as you're here. If you don't believe me, take a piece of paper, and hold it on the side of your eye and tell me, go ahead and read that paper. Can you read it from peripheral vision? No, you have to kind of put it in front of your eye. Well, that's what a game developer does. And that's something that you have to think and consider when you design things. What is the real user experience? And that's an application specific thing, not a protocol specific thing. You don't, as a developer, get the luxury of changing TCP/IP because you'd like it to be 50% faster for your thing. You just don't get to do that. It's not possible. And it's the same situation when you look at any normal web application. So one part optimization and better tooling, one part getting a better interplay between on-chain, off-chain, understanding your different domains, partner chains, zones of fast finality, tiered pricing so you can optimize your pricing and you pay for how fast you want things to settle, and then truly protocol design. We're the only project in the entire cryptocurrency space outside of Ethereum that really has an end-to-end holistic view, and contrasted to Ethereum, instead of it being fragmented through many different providers and radical different philosophies, there's actually an end-to-end group of people, many companies consolidated and working together on one common vision about how to do this, which means we'll have it faster and better. And more importantly, once we get it, it becomes just a commoditized thing that's there forever inside the protocol. You all take advantage every day of liquid non-custodial staking. You all take advantage every single day of the determinism of the transaction model and extended UTXO and how easy it is to issue a Cardano native asset. You don't think about that. And future innovations, because of the design philosophy, don't regress. So it's not the case that when we go to Laos, that suddenly everything is custodial and non-liquid, and we have to adopt an Ethereum-style staking model. You preserve that in that security model, and you enhance and augment it. So what does this translate to? We're too successful, so we're a failure. The restaurant is too busy, so it's going to go out of business. It translates to this is a vibrant project that people love, appreciate, and they're excited about, and it's going places. Cardano is being used every day, and there's a high demand every day, and it's exciting as a protocol architect to see that level of adoption and see that people are doing that. It also translates to that we actually know as an ecosystem what we're doing. We know how to go from Mario 1 to 3, and there's a lot of good people waking up every day making that happen. A lot of people are rewriting their applications. MinSwap is upgrading, SundaySwap is upgrading to be more efficient and judicious in the use of on-chain resources. There's everyday progress on your off-chain to on-chain transactions, your Hydra. There's progress happening with Mithril, and there's amazing innovations happening in the lab when you talk about on-chain sharding that preserves and protects the integrity of the system. And then it'll get implemented, and it'll go into Cardano. And what will happen is the goalposts move. That's probably the most frustrating part of it. First, when Shelley, then when Goguen, then when Coinbase, then when this, and when this, and when this, and when this. So the minute we achieve that, somebody's going to complain about something else inside the system. So never get trapped in that loop, the hedonic amnesia, where you can only feel joy for a brief moment. Do understand that this is a web of principles, and it moves as a homogeneous unit from one state to the next state. And every time we get there, we preserve and protect the things that are important in that web. That's what makes Cardano special. It doesn't compromise, and it finds a way to get it done despite that. The road may be a little harder, Might be a little longer, might be a little bit more confusing, but we all get there together, and you have rights in the Cardano ecosystem that are very important. Eventually we'll be inscribed in constitutional rights in the ecosystem, which are on chain and people can see them and audit them. It's there. And the peer review process, what it did for us is it told us the design space, and it gave us a good sense of what we can and cannot do from a protocol design viewpoint. And it's always easier to relax things than go stricter, because every time you go stricter, you reduce functionality and you take something from somebody. So start conservative and then open up when it's safe to do so. That's always been one of the core principles of the project. So I figured I'd make a quick video and kind of take you guys through and show you that this is a complicated thing, because you'll see a bunch of FUD. You'll see a bunch of people running around, and it's like, just remind them of the restaurant analogy. We're getting there. And I know at times it can be a little frustrating. It sucks to wait in line for a good steak, but it's worth it at the end of the day. And also that security is never compromised, and the network as a whole is doing quite well. There's not many things in life that can run at 90, 95%, 100% of load, like redlining your car engine, for example, and have that thing just do it 24 hours a day, 7 days a week with no problem. That is a testimony to the methodology that was followed and the engineering that was done inside the system. It's really amazing to see that. And it's really exciting to see that. It makes me happy. It makes me excited. And I do believe our best days are ahead of us from that perspective. And I hope this gives you some insight to how complicated these things can actually be. Most people don't think this way. It's saying, hey, hang on a second here. Where does this need to live? What level of privacy does this need to have? Is this persistent or semi-persistent or ephemeral? Is this for a one-time thing? Is this a permanent thing? Am I going to come and refer to this on multiple occasions, or am I only going to use it as an intermediate form and then it's instantly going to go away? Is this a small value transaction, high value transaction? What is my settlement desire? Do I need it to settle right now, right here in 1 second, or can I wait till tomorrow for that to settle? It's just important that it posts so I have the auditability of when it was broadcast. All these things, like all of that goes into your usability, and every one of you have different dApps and expectations of that, and they translate accordingly. So all of that is that Mario 1 to 3. And then Super Nintendo is basically just taking that beautiful model and taking it and supercharging, making it the next big thing, the next generation. And you open up all these new amazing capabilities inside the system, and then suddenly you have something that people have never seen before. And it would be one thing if we didn't know how to do it, but we do. It's not a question, unless you guys are questioning the 204 papers that are published, unless you're questioning the fact that the model works. This is not a commitment or a promise or a misexpectation. It's here. Cardano's running. Everything we said was going to happen in terms of how Cardano operates and what does it's occurring. It's 7 years of track record people can look at. Maybe things didn't happen as fast as people wanted, but it always happened in the end. We're here today. It's one of the most decentralized protocols as measured by EDI. There's amazing stuff happening. There's tons of projects building on it. If there's tons of projects not building on it, why would we have blocks that are full? Or is it just junk? You can go to Extended UTXO and see it real time. It's there. And governance is turning on, by the way. It's also got the largest and best decentralized governance in the history of any cryptocurrency project. That's a very powerful thing. So those commitments were made and they've been honored. And as I said, I predict thousands of dApps and tons of native assets. It kind of seems that way, doesn't it? It's there. You can go and see them real time. Go to Tap Tools and just see how much is there. It's amazing that projects are raising funds on Cardano, and they've raised twice as much money in some cases as the totality of the Ethereum crowd sale. And nobody in the crypto media reports it or cares about it. Again, because what do? They move the goalposts. They always move the goalposts every day, no matter what we achieve. Because at the end of the day, to admit that something like Cardano exists is very dangerous. The longer we exist, the more we do, the more we accomplish, the bigger the contrast Cardano is from its competitors. The more centralized you realize the competitors are, the more fragile you realize they are, the more you realize you don't have any rights in those types of systems, and how those systems are very, very risky to many vectors of attack. And the problem is they can't change their underlying designs, because they would have to go and wind back the clock and copy us and tell me, was it a fast, easy process to build something like Cardano? No. The technology is really hard to build. So backward engineering that, copy pasting that is a very difficult endeavor. It's not going to happen. So the only thing you can do to fight that is either to undervalue the things that we value, which over a long arc of time, people really learn how important they are. It's just like freedom of speech. You may not value it much in the beginning, but the minute you get arrested for saying the wrong thing, you start realizing, oh, hang on a second here, that was an important right. Over the long term, you realize how important it is. And then also that ability to have freedom and options, the modularize. Extended UTXO allows great state channel isomorphism and translates to easy to do off-chain and on-chain together. Harder paradigm for some to program in, but you get so much downstream benefit from it as people are starting to wake up to and learn. And it's the same with Leos. It makes it much easier for us to pursue sharding that makes sense without running the problems that Ethereum ran into in 2018 and 2019 when they thought that they could achieve 1 million TPS and shard the ledger and those original roadmaps. Don't believe me? Look at the roadmaps historically and the kinds of statements that team was making. Were they dishonest people? No. Were they bad people? No. It's just they didn't fully appreciate or understand what they were saying and the complexity of what they were saying and the devils in the details, and they had to become more nuanced over time. We did understand and appreciate how difficult these things were and are. And you know what we did? We followed the right process as an ecosystem. And we understood you had to divide and conquer. And it wasn't one size fits all. You have to give yourself wiggle room in the protocol to increase block size, optimize network utilization, and more judiciously use the space you have. You have to form marketplaces for the use of that space. You have to have upgrades to your protocol that allow you to easily go on and off chain and encourage people to use those paradigms where and when they make sense. You have to get services which are clearly services like, Ask Ben or World Mobile or whatever, and get those things to run as partner chains so they don't clog the network. You have to have the ability to deal with ephemeral things. You have to have the ability to deal with private things. And then, yes, you have to have layer one sharding. And you have to do that in a way that preserves and protects inclusive accountability, doesn't put the stake pool operators out of business, especially the small stake pool operators, and also preserves the security model you all take for granted that the rest of the space is looking to quantum computers to attempt to bring to them. It's that simple. So know what you're asking for, and also know what signs of success look like. And don't be gaslit into believing that the restaurant with a long queue and a lot of people are going to every day and are excited about eating at is going out of business. It's quite the opposite. Cardano makes a good steak, and we got a lot more meat to cook. So thanks for listening. Cheers.